Okay, in this video we continue with Larson, Chapter 4, Section 1, and this time we'll be looking for indefinite integrals, or finding indefinite integrals that have to do with trigonometry. So let's look at number 35 then. For 35, we have the integral of 2 sine x minus 3 cosine x dx. And the antiderivative of sine is negative cosine. So the first would be negative 2 cosine x. Then the antiderivative of cosine is just sine. So minus 3 sine x and plus c. Next, number 36. We have integral t squared minus sine of t dt, and so t squared is t to the third over 3, or 1/3 t cubed, then minus the antiderivative of sine, which is negative cosine, and so that would be plus cosine t plus c. Number 37. We have the integral of 1 minus cosecant t cotangent t, and you want to recall that the question is which function has a derivative negative cosecant cotangent, and that would be cosecant. The derivative of cosecant is negative cosecant cotan, and so we would get, for the 1, we're going to get a t here, and then plus instead of minus cosecant of t plus c. All right, going on to number 38. So we have integral theta squared plus secant square of theta d theta. When theta is our variable, theta squared is going to become, the antiderivative of theta squared is theta to the third over 3, or 1/3 theta to the third. Then secant squared, we're going to ask what is the function whose derivative is secant squared, and that's just tangent of theta and plus c. So don't get trapped in the increase and divide there. You're looking for which function's derivative is secant squared. All right, number 39. We have integral secant squared theta minus sine theta d theta. So again, the antiderivative of secant squared is tangent theta. The antiderivative of sine is negative cosine. So now we'll get plus cosine theta plus c there. And number 40. For number 40, we're going to want to multiply that out. So secant y tan y minus secant square of y dy. Again, we ask which function has a derivative of secant tan, and that would just be secant. So that is secant y. And then which function has the derivative of secant squared? That's tangent. In this case would be negative tan y plus c. All right, for number 41, we're going to start to use some identities. So you know, for example, that sine square of x plus cosine square of x is equal to 1. Well, if we divide through, we're looking for a tangent squared. So we want to divide through by cosine square of x, cosine square of x, cosine square of x, and we get tan square of x plus 1 equals secant square of x. And so we're simply going to write number 41 as integral secant square of x dx. We know that the function whose derivative is secant squared is tan squared. Is just tangent, sorry. And we should be writing in y's here. And so we get secant square y dy, integral of secant square y dy is tan y plus c. And for the final one, number 42, alright, so for 42, we are, by looking at the denominator, that's 1 minus cosine square, which is sine square, from the Pythagorean identity, simply subtracting cosine square of x from both sides. So 1 minus cosine square is sine square. And so we would have integral of cosine of x over sine square of x dx. Now that alone doesn't really help us there, but if we were to split that up and do something like cosine x over sine x times 1 over sine x dx, then we would get integral cotangent x cosecant x dx, and which function has a derivative of cosecant cotangent? Well, actually it's the derivative of cosecant is negative cosecant cotangent, so this would be negative cosecant x plus c. And those are some of the different flavors you get when you're finding indefinite integrals of functions involving trig. Alright, so that'll be it for this video.